Well, well, what has the cat dragged in today? It's a tutorial on game state. So we've almost got everything finished in our Plinko game here. If we hit the run button, we have the ability to move the ball back and forth. We can release it. It bounces in weird and unpredictable ways. And when it falls down, it changes the color of whatever goal that it hits. And if you hit the same goal more than once, it doesn't count towards victory. We have to get all of these blue before we win. And that's what we're going to look at today. Winning. How do we know when we've won? And how do we alter the state of the game based on that? Now, despite the fact that I keep using the word state, we're not actually going to be taking a look at Bolt's state machine functionality yet. We're still going to be working with flow graphs because we definitely do not need a full-on state machine here to keep track of things. And so just like we asked the question last time as to where our goal logic should go, we need to ask the question, well, where should our game state logic go? Because there's no real good way of phrasing things. It's like, okay, so when the ball hits the last goal, the game state changes to victory. I could try to rephrase it. So like if the goal is the last goal to be hit, then the game state changes to victory. There's no way that I can phrase that question such that I can keep everything on an existing object. And you know what? That's fine. Sometimes we need a game object that just exists solely to hook logic onto. So I am going to create an empty game object, which I'm going to call game logic. And even though this thing's going to have no physical presence, so to speak, in the game, I'm still going to reset it back to the origin. Always a good idea to do that. Don't leave objects floating off in weird positions in 3D space. And I'm going to add a flow machine onto this, and I'm going to embed it. Again, this is a one-off object. It's not going to exist in any other scene because there are no other scenes. And so embedding the flow graph makes sense. If I was doing this into a full-fledged game where I would have multiple boards and all the boards would be sharing the same logic, I'd probably want to make this a macro. But in this scenario, an embedded flow graph is just peachy. I don't need to start. There's nothing I need to initialize. There's only one thing my game logic really needs to do. And that is, every frame, ask the question, what is my hit count? Is my hit count equal to 5? And if my hit count is equal to 5, I need to do things. Now let's get that set up. At least the first portion of it, because the do things part, we got a little bit of additional work in the scene to do for that. So I am going to do a branch, and what I am going to base my branch off of is I'm going to take hit count, and I am going to ask the question, hit count, are you... Now, I could just do equal to. I like doing greater than or equal to because I'm paranoid. And if somehow the user manages to skip the number 5 and get that hit counter to 6, I don't understand how they would do that, but never underestimate users. And if you think you do understand your users, I got 2 YouTube video channels you should go watch. The Spiffing Brit, and Let's Game It Out. And then tell me just how well you think you can control your users. So I'm paranoid. So rather than checking for equal to 5, I am going to check for greater than or equal to 5. Because, something weird happens and it jumps up to 6 or 7 or 200. Okay, the player still won. So there we go. Now, what do I need to do? Oh, there's a couple of things that need to happen. One, I need to destroy the ball. I don't want the ball to continue to bounce around. Now, how do I get that information? Because this game object, as it stands right now, has no concept of the ball game object. So what I'm going to do, well, there's a couple of ways we could do this. We could use GameObject.find. We could do a find by name. We could do a find by tag. Rather than doing any of that, I'm going to do an object variable and use a reference. So I'm going to go in here to object. I'm going to create a variable called the ball. And I'm going to set its data type to object. And so this is true. So I am going to destroy whatever is held in this variable reference. The next thing that I need to do is display a "you win" message to the player. And oops, I don't have a "you win" message ready to display, so let's go create that. Now to do this, I'm going to use Unity's UI system. I'm not going to go into depth here on the UI system, mainly because there is so much to cover. I have multiple videos, very dry, boring videos, I must admit, covering the UI system. It's hard to make that interesting, okay? But the basics. In Unity, if you want user interface, or UI, you can right-click, UI, and you've got a bunch of options here. The only option I am going to worry about today is text, because that's all I need. The ability to display text to the user. And you'll immediately notice that, oh my, this is rather large, isn't it? Yeah, so the UI system's a bit special. First, in order to work with this, I'm going to want to switch my scene to a 2D view. That flattens out the perspective. There's no more perspective now to this scene. The second thing I'm going to want to do, because I don't want to get carpal tunnel and I don't want to ruin my mouse wheel, is I'm going to focus on this canvas object that was created, either by double-clicking on it or selecting it and pressing the F key. There's my tiny little text box down there. Okay, so what happened here? I created a text element, not a canvas, so why do I have a canvas and why is my text a child of it? Well, the way UI works in Unity is that all UI elements must, absolutely must, be a child of a canvas. There is no exception to this rule. It must be a child of a canvas. And we can get pretty complicated with this, with having canvases that are children of other canvases to sort of divide up the screen and all sorts of shenanigans. And we can have canvases that are overlays, which is what the default is. That's what we've got here, is an overlay. We can have canvases that appear based somewhere on the camera's view. We can have canvases that appear in world space, all sorts of fun options. Not going for any of that. We just want you win displaying in the center. So I'm not going to take a look at any of the other settings on Canvas here. I'm just going to go straight to my text box. Now, by default, when I switch to the 2D mode, it should have switched to, and it did, the rectangular select tool. That's generally speaking the tool that you want to use when dealing with UI elements. Mainly because it gets you this nice handy-dandy little snap. You see, as it gets to the center, it sort of snaps into the center line there. And it makes it very easy to keep it on that center line. Something else that you always want to pay attention to are anchors. You always want to have this anchor point, ideally, generally speaking, as close as possible to the UI element. So in this case, since I do in fact want my box, which I'm going to make a lot bigger, I do want this roughly centered on the screen, maybe a little bit higher. Having my anchor point in the center works fine. And you can change the anchor points by clicking on this little button here and selecting the appropriate anchor point. Generally speaking, like I said, you want this to be as close as possible to where this UI element actually happens to be. If I look over in the inspector, I can see that this text game object has a text component on it. That's the main thing that I'm going to be messing with. And I'm going to put in the message "you win," which is currently this itty bitty little bit of black text which we can't even see on our screen. So I'm going to do a couple of things. First, I want this text to be centered. If I increase my font size, you can actually see it now. Instead of being in the top left, I want this to be centered. So I'm going to come here to paragraph alignment, and I'm going to make sure it's centered both horizontally and vertically. And then I'm going to left-click drag on font size until I get it large enough that it completely takes up the box. Too large and it disappears. Bring it down a little bit. There we go. Now it's still really kind of hard to see in my case because I have a dark background. So I'm also going to change the font color. Which again, if I look down here, I have a color property. I'm going to click on that bar. And I'll change it to a little bit of a dim green there. Come over here and look at game, and "you win" scrawled across the screen. Permanently scrawled across the screen. Ooh, that was one heck of a bounce. Which is definitely not what I want at all, in the slightest. I don't want to see this until I've actually won. So how am I going to do that? Well, first, I am going to select the canvas game object that the text is a child to. Actually, the first thing I'm going to do, before I forget, is I'm going to rename that text box. Okay, why do I put LBL in front of it? That is most definitely a personal quirk of mine. When it comes to UI, I tend to put a 3-letter code in front of the name so I know what it is. LBL stands for label, meaning it's text that should never change. TXT is for text that does change. BTN is for button, so on and so forth. Personal quirk, so I can tell at a glance which of my UI elements is what. Now I'm going to go to the canvas game object, and I'm going to disable the canvas game object. It still exists in the scene, but since it's been disabled, it's no longer visible. Now I can go back to my game logic flow graph here. And I can continue on. So the ball, I'm going to destroy. That canvas game object, I have to turn back on. So I'm going to create a variable called canvas of type game object. And what I'm going to do is I'm going to go set game object dot set active. And I'm not going to set self. Instead, I am going to set the canvas to on. So I'm going to put the little checkbox there. So I am setting active. I'm going to set the canvas, or whatever this reference is pointing towards. I'm going to set that value to true. Now there's one last thing that I need to do. If I was to leave it like this, it would work, but then I would run into an error because every frame after I reached the score of 5, it would be trying to destroy the ball. But after that first frame, the ball no longer exists. So I'm going to be generating an error, and we don't want that. So after this is all done, I need to do something. There's 2 ways I could do this. I could change the hit count variable back to less than 5, and that will stop the logic. Or I could just simply destroy game logic. It's not needed anymore. It's done its job. I can just get rid of it. So I'm going to destroy object, and I am going to destroy self. And there we go. That is it. Let's test it. Again, because I am testing, I am going to disable my peg group there. So that way I can easily go through and test hitting all of the boxes. Okay, well, that was slightly unexpected there. Okay, and I'm getting errors. This is turning up red, and yeah. And the ball still reset back up to the top. What happened? Oh, null. Oops. Yeah, so you have to make sure that you set your variables. So I didn't actually link up the references like I was supposed to. This is a common error that you will encounter as you're doing development, is you'll create a variable that's intended to be a reference to something, and then you'll forget to link up the reference. So that should be one of the first things that you check anytime you get messages like this, missing target object, when you're dealing with Bolt, or in the case of C#, null reference exception. That means you probably forgot to link something up in the inspector. So the ball, that needs to be a game object, and I will drag, where's the ball? There it is. I'll drag that in. And canvas is a game object, and I will drag in my disabled canvas. Now it should work. And this is also why you constantly test. Every time you get a little bit of functionality implemented that is testable, you should probably give it a quick test to make sure that it's working, because the sooner you find the bug, the easier it's going to be to correct. Excellent. There you go. That is exactly what I wanted to see. The ball has disappeared. You win shows up. I have no red messages of doom in my console. Bingo. Let's turn our pegs back on. And we now have a functional Plinko game. Move the ball back and forth. Bounce around. And see how long it takes me to actually win when I've got all of the various little bits and pieces in. No! Having that random element really does make things a bit more interesting, which is why we put that in there. It also can be a little bit frustrating at the moment, because I'm just sort of like, come on, really? You can't just fall mostly straight. No? Okay, you can't fall mostly straight. Yeah, it looks like that one box there is just like, yeah, no, I'm good, thank you. You get the point, however, and goodness gracious, am I having some bad luck. There we go, finally. Yes, I win. Thank you. And of course, there's some fun things that you can do with the project at this point. You can experiment around with the spacing and how many pegs that you want. You can experiment around with the weight of the ball and how much force is added to it and how much torque is added to it when you release it. You could try to increase the number of goals. All sorts of fun little tweaks that you can do at this point to try to make this project a bit more of your own. And well, that finishes things up. You now have a complete Plinko game that you have made. And as always, if you found this video useful, you enjoyed it, thumbs up would be appreciated. If not, well, the thumbs down button is right next to it. See you guys in the next tutorial sequence.